Okay, so we have a few things to talk about this week, but one of them is scatter plots. I know you have done scatter plots before, so the purpose of this video is just going to be to remind you how to do scatter plot things by hand. In class tomorrow, we'll be doing some practice with your calculator so that you can learn maybe some quicker methods and maybe some more accurate methods for relating with scatter plots. All right, so if we go ahead and dive in here, scatter plots, you know what they look like. They're a graph which relate two sets of real-world data. And this is really probably a more honest real-world application of anything that we're going to do this year. All the time in marketing and a lot of different fields, people are going to use scatter plots, use this concept to map data to find trends so that they can use that to predict sales, to predict how many things they need to purchase, to predict what they're going to make in the future, those types of things. All right, so we probably also want to make a note that scatter plots are used for predictions. All right, and also I've added here that they can be used to map trends so that we can see how things are related. So correlation is our math word that tells us that how data is measured. So a correlation is the measure of how the data is related. All right, and then there are a few different types of correlation. So I'm going to kind of pause with filling in these blanks, and I want to turn your attention to this set of graphs over here on the right-hand side of your paper. So you may notice the first type of correlation, which really isn't any correlation, is called no correlation, and those are things that aren't related at all. So you may notice that these first two graphs in each of these sets are going to be no correlation because they're not really, there's no pattern between what's happening. So I'm going to call these no correlation on both of them. And you can circle them or write, it's probably going to be harder for you to write over, but somehow label that those are no correlation. Now, there are two other kind of sets here that stand apart. So this first set, to me, it becomes very distinctive of the second one because all of these appear to be increasing as we move to the right. So this is what we call, this whole top set is what we call a positive correlation. And then if you notice, you all have talked about positive and negative correlations before, but there's something kind of distinctive going on here. So there is a separation, not even just positive and negative, but even within positive correlations. Notice that this last graph down here becomes like a perfectly straight line. And these others are spread apart, and some of them are even more and more spread apart, like this top one on the first row. So the more spread apart the points are, so we're talking about things that are not as condensed, right? We're going to call these weak correlations. So this is weak positive, and I'm going to say both of these are examples of weak correlations. And then we're also going to have some strong correlations. So that's the opposite of them being weak. And if you think about that, what I want you to know, and we'll add this in our notes on the other side, the stronger a correlation is, the better it is for predicting future values. So if we think about that, like this strong correlation, this could be an example of something between wingspan and height. And this would be strong because a person's wingspan, or how far apart they're like fingertip to fingertip if they spread their arms out, is generally about the same as their height. And when I say it's a good predictor, if you think about that, when I pick wingspan here, there are like not very many data points that vary. Your wingspan is pretty much exactly your height. However, if I think about age and height, all right, so I've moved over to this other weak graph. If I think about age versus height, it's not as good of a predictor because even think about the kids in your class, right? A lot of you are pretty much the same age, but when we think about your height, the height range varies a lot. So we call this weak because if I pick a certain age, my area of prediction becomes much greater. It becomes more difficult to be accurate when I'm using that as a predictor. All right, so this is positive correlation. At the bottom there, negative correlation is really kind of the same. So this whole set is negative because we're going down. And then we can go ahead and label, and I want you to do that for yourself, label which ones are weak and then which ones are strong negative correlations. All right, and the last thing we need to note, there are all of these R values down here. And I want you to pause the video and take a second to think about any relationships you see there. And hopefully you find that the stronger the correlation, the closer this R value is to 1. So notice, like, if it's perfectly 1, that's a perfectly straight line, be it positive or negative, right? But if I go back to 0.9, it's still a pretty strong correlation for both positive and negative. But if I go back even further, like the 0.6, that gets really weak. Think about that as like grades, right? If you get a 60% on a test, I mean, like, you're getting 60% of them right, so you're getting more right than you are wrong, but it's still, you're kind of all over the place, right? Like, that's not like a very good predictor or very good grade. Whereas if you get a 90, you know, think about that, like, you know most of your stuff. That's a much stronger prediction because you're tighter together, if that makes any sense. All right, so let's kind of fill in our notes with all that stuff that we just talked about. All right, so we're going to add that there's a correlation coefficient. We're going to add 2 bullet points. I'm actually going to pause the video so I can fill those in, and then we'll talk about them. All right, so here are the 2 points we want to add. Correlation coefficients, they're referred to as R, or sometimes you're going to see R squared, indicate stronger correlations when they're closer to 1. So we want to put that in there. And then strong correlations are better predictors than weak correlations. This next bullet point that's already written for you, real world data is not always related linearly. So 2 things there. 1, it's not always related, as in no correlation, but you may also see things that are related, like they kind of curve up. And if you see curves, those are just going to be not linear. And we're not talking about those at all this week, just lines. But I wanted to go ahead and put that out there for you. All right, and then our last blank here, a line of fit. It's also sometimes called a line of regression. You're going to see that word a lot. That's like the fancy math word for saying line of fit. So you're going to see regression a lot. And what that does is it's a straight line that runs through the middle of the data, so to speak. All right, and I'll talk more about kind of how you pick that and what that looks like here in a minute when we look at some examples. So the how-to is really just a question about how do we write this, which is a drawing on what we did last week. So we want to, let me fill in this and then you can pause and fill that out for yourself. All right, so this is just kind of a review from last week. You're going to pick 2 points, and some of us may not pick the same points, but our goal will be to pick 2 points so that when we sketch the line, it hits the middle of the data. Like I said, I'm going to show you an example in a minute. Then we're going to find the slope. So think about it. You're going to be given 2 different ordered pairs, right? This is just like what we did last week. So you're going to find the slope using those. And then we're going to set up y minus y1 equals m times x minus x1. That's our point slope formula. And then we're going to get this into slope intercept form because that's what's going to be the most helpful as we work these problems. Now, a lot of times I get some people that want to argue about if something is a positive or a negative correlation. So we talk about what are the exceptions. Okay, so let's think about if we did hours studying versus your grade. All right, and the idea, I think, generally is that the more you study or the more time you spend doing your schoolwork, the better your grade is going to be. So in general, we've got this like positive correlation. Now, what I've drawn here is a pretty weak positive correlation. It's not all grouped together, but it's not the weakest. But think about what are the exceptions to this, right? If I tell you the more you study, the better a grade you get, what are the exceptions? Well, you may be thinking about a person, so you could fall on either end of the spectrum. You may be thinking about, well, you feel like you study a lot and your grade still isn't good, so you might be this person down here. All right, you studied a lot, but your grade's still not great. Or maybe you don't study at all and you have a really, really good grade. And those people are annoying, right? Okay, so both of these people, we call them, and not even people, they're just data points. We're going to call them outliers. And outliers are going to be points that do not fit with the rest of the data very well. And we will talk about, as we start to get into things with your calculator, what we do with outliers, because sometimes we can't do anything, but sometimes if we ignore this person, we can get some better predictable trends. So know that outliers are just going to be our people that do not fit, or our data points rather, that do not fit with the rest of the data very well. All right, so we're not going to worry about this page until we're in class together. So let's go ahead and move on to the second page. And what I want to do here is just a few examples with you so that you feel like you're on the right track for class tomorrow. All right, so I'm going to look at question 1 with you, and I'm going to do a few things other than just what the directions say. So this question is asking me to predict how many CDs would be sold in 2006. Now we're predicting, so we're not going to come up with an exact value, but if I look here around 2006, so I notice the x-axis is counting by ones, so 2006 is going to put me on this last line here. I can kind of just think about if I made a point and I wanted it to follow in this trend, where would that point hit? So to me, anywhere kind of around 650, like that seems to fit for me. If I erase that point and put one maybe at 625, that still seems like it's in a pretty good range. 675 seems pretty good. At 675 kind of seems a little high to me. I don't know about you, but there becomes a point where it's very obvious that what you're picking is not a very good fit. For example, if I pick 700, you can kind of see that that doesn't really fit the data very well. It's like it's too high, right? You're trying to make the data level out there, so that's not a good point to pick. So I'm going to say a good range would probably be, and I'll mark this on our graph, anywhere maybe between 625 and 675. I think if we put any point in this section, that would probably be a pretty good fit for our data. And you may have a case against that, and we can certainly talk about that tomorrow. One of the nice things about scatter plots, but it's kind of annoying for some people, is that there could be a lot of different kind of right answers. All right, so our answer here is going to be, if the trend continues, how many CDs would be sold? I'm going to say around 625 to 650. Now, it's not 650 CDs, it's 650, or 75, I guess, rather, is what we said, million. So notice what the graph is counting by, that we're counting in millions. So you want to actually use that word. So 625 to 675 million CDs. All right, now I want to zoom back in on this graph because this is not what the question asked, and think about if we were to draw a line, what would that look like? So remember, step 1 is to pick 2 points that we could draw a line through. Now, on this example, I want to pick 2 points so that when I draw a line, it kind of hits through the data. So let me show you some things that don't work. A lot of times I have people say, okay, well, I'll pick this one and this one, because if I draw a line, it's going to hit the most amount of data points. Well, that's good, but to me, that's, and some people even say, well, this is a pretty fair explanation because I've got 1 data point below and 2 data points above, so this is going to be a good predictor. But think about if I keep this line going, that's going to give me like a way low prediction for 2006. It doesn't really seem, even though it's hitting 4 of the data points, it doesn't really seem to match very well to me with the entire amount of the data. So I don't actually think that's a very good line. And if it were me, if I were trying to pick 2 points that would be better, let's see, I think maybe even like this first and the last point would probably fit with most of the data better, because I want as many data points as possible to be really close to this line. Okay, so if I do that, I now have a more even set above and below, and it looks like most of these data points are relatively close to the line that we're matching, right? They're all kind of close there. I don't have any that are way, way far off. So that's what we say when we're saying pick 2 good points to draw a line through. All right, so that being said, let's try question 4 together. And you all can try questions 2 and 3 on your own if you want to, on your own time, but I'm going to go ahead and move on to question 4 down here at the bottom. So part A says they want us to draw the scatter plot. Now I want to point something out to you. On this graph, two things. One, it's not labeled. So in your table, it says X. It doesn't actually say this, but it tells you what the study hours are. Those are our X. So study hours. And then obviously we're going to have grade is our Y value here. And we have to come up with what to count by. So another thing I want to point out to you, notice this little kind of heartbeat looking symbol at the bottom. That means that we are skipping a few numbers and we're not actually starting at 0. So we need to keep that in mind because it could be that part of the graph is irrelevant. So for study hours, if I look at the numbers in the X column up here at the top, I think if I count by ones, I can fit all of those data points on my graph. So I'm going to do that 0, 1, 2, 3, 4, 5, 6. Now I know it doesn't go all the way to 7. I'm just numbering because I can. And then grade, think about where we want to start this graph. And to me, it looks like 60 is the lowest. So I'm going to make 60 my starting point. And if I had started at 0, what would happen is that all of our data would just be squished up here at the top, and we would have a whole empty space of the graph at the bottom. I don't want that. Now we need to think about what we're going to count by. And we can count by tens. If we did that, that would be 60, 70, 80, 90, 100. But that's going to kind of give me the same problem because now all my data is going to be squished in this bottom part. I want it to be as spread out as possible so I get a better picture. So I just want to check if I count by fives that it will work. So if I do that, 60, 65, 70, 75, 80, 85, 90, 95, 100. All right, so this does go all the way up to 100, or at least to 92, which is my highest value. So I think that counting by fives is going to be a good idea. So what I'm going to do is pause the video and complete this graph. I would like for you to do the same before you see what the answer is. All right, so this is what my scatter plot looks like. I would like for you to just to make sure that you have the same thing before we move on. All right, so the directions are going to ask us to draw a scatter plot and draw a line of best fit. Now, I would like for you on your own to pick 2 points that you think would fit the best and draw a line of fit through those 2 points. Okay, I am not going to match this, so you need to do this on your own so we can compare them tomorrow. All right, part B says, what is the equation of the line? Now, last week we did everything in fractions. This week I'm going to let you do decimals. So if you find something and you start getting a fraction in your equation, just change it over to a decimal. That's fine. You are going to use the 2 points that you picked, do point slope form, and then change it into a y equals mx plus b equation. So go ahead and do part B. And then we're going to talk about, so for part C, if we're going to predict the grade for a student for 6 hours, that would be like us, so I'm going to bring back kind of some old notation, that would be like us doing f of 6 with the equation that we found in part B. So what I would like for you to do is go ahead and do f of 6 for the equation you have for part B. All right, and then part D here says, could the line go on forever? So I'm going to have you go ahead and answer that question, and this is where we're going to pick up in class tomorrow. We're going to go over this example together.